Perfect. I see the first people are joining the webinar. We've just opened up right on time. And yeah, great to see that so many people registered again. We have a special guest today, so I'm pretty happy to see that people felt the same way about it. And yeah, the numbers are going up. And I'll wait a minute so they stabilize before we hit it off and start straight away. In the meanwhile, we'll do introductions in a minute, but yeah, thanks Sergio and thanks Amaël for joining the first webinar together.
Yes, thank you very much for inviting us.
Thanks to you for the invitation.
Great, amazing, amazing. Perfect. So the numbers seem to have slowly stabilized. Probably some people are always joining in the meanwhile. In any case, before we really hit it off, just some recommendations. Please have a mobile phone next to you, or in case you don't have your phone with you, a web browser, because that will be your way to interact with us. And at the end for the Q&A, but also in the beginning, we'll do a little icebreaker. And of course, feel free to take any notes. In the end, we will also be sharing the recording. But yeah, feel free to follow. And so let us introduce ourselves before we start. So myself, I'm Tommaso. I'm the Native Lab manager within Managing Composites. At the Native Lab, we have a platform of different training programs on composites. And among other things, we host these webinars where we try to invite people from the sector, and we collect them as our composite talks. And yeah, today I have the pleasure to have two very special guests with us. The first one is Sergio de Juan, R&D manager of Managing Composites.
Hi everyone. Yes, I'm Sergio de Juan. I'm the R&D manager in Managing, and well, I'm also the material expert. I'm trying to coordinate all the research actions within the company.
Great, thanks. And another very important guest, Amaël Cohades. I hope the pronunciation is getting better slowly from CompPair.
Yeah, thanks a lot. So pleasure to be here today also and to introduce more what we are doing at CompPair, but I will leave that for after. Shortly about myself. So I have a material science background, performed studies here in Switzerland in material science, then pursued a PhD in self-healing composites, and then after the PhD, we started to understand how to give self-healing the capacity to become commercial, and that's what we have done, and then launched the company. And since that time, I'm CEO of the company, and so taking care of a lot of different aspects, but including as well all the this kind of webinars that I'm looking as well to explain everything around what we do at CompPair.
Perfect, great. Thanks for introducing, guys. And now a bit more about you. We always like to know our audience, so we can adapt also the webinar and the interview and go a bit more in that direction. So for that, as I said, have your mobile phone with you or a web browser and go to menti.com. And when you reach menti.com, give me a second. Perfect. You can either insert the code you see on the bottom left, which is 46825995, or use the QR code on the screen. And then we'll start with some questions. I see the first people are joining in. So again, you can go to menti.com and then use the code as you see on the left, or scan the QR code and you'll be ready to go. I also want to mention, through Menti, you'll be able to send us your question. Throughout the entire webinar, you can do so. At the lower part of your screen on your mobile phone, there should be a little button saying Q&A or questions. You can always send your questions through there, and at the end we will go through them. Okay, having said this, I think most people are in. So first question, years of experience with composites. So 0 to 2, 2 to 5, 5 to 10, or plus 10. Okay, the numbers are going up. For now, the winner is people who are starting off in composites. 0 to 2, and the others are more or less equal. Let's give it a bit to see some more questions. Where are you, Sergio? Plus 10, 5 to 10?
I would say now plus 10. Yeah.
Plus 10.
Yeah.
And I think Amaël is the same, no?
More or less.
More or less. Okay, good. So you've got some competitors today, probably some tough questions coming at the end. Okay, but good to see that there are also a lot of new people into composites who are interested in hearing more about self-healing composites. Great. Next question. So what is your main interest within composites? So I've added materials or R&D, so a bit more what Sergio and Amaël are into, manufacturing, composites design, simulation, or you can go for all of them. I would expect most people to be interested in materials since the topic is about that. But good to see that there are also some people from manufacturing, some people from design, and some people, of course, love the entire scope of it. Sergio, you are clearly R&D, as we said in the beginning, and I think Amaël, you're also more on the R&D side. But as CEO, you probably start getting into most of them. Perfect. Great. I think there are still some people voting, but with no further ado, let's jump back to the presentation and get the ball rolling. Okay, so let's start. Let's start our webinar on self-healing composites for sustainability. And I mean, we thought of inviting you, Amaël. We thought of inviting you because you work at CompPair, which is a very active company in the field. So, I mean, I guess there's been research on the topic already for a while, but yeah, we wanted to know a bit more the story behind CompPair, also considering now the topic of sustainability, how important it is in the composite sector and among. And yeah, if you can tell us a bit more, the story, some nice insights, how everything started, and start getting a bit of a grasp of what your composites or your materials entail.
Yeah, thanks a lot. Thanks a lot. So the where it started is self-healing composites have started to be researched in the years 2000s, more or less. It's coming from a famous lab as well in the US, and all that with the initial strategy of saying, okay, we need to be fully autonomous healing. And actually, and this is one thing that I think I will come back to that as well throughout the webinar, but starting with one single paradox is being inspired from the human body, because the paradox is that all of us are able to live for like 80 years, maybe 90, hopefully 100, but all the materials and all the applications that we have around us, like, and even not of composites, but even our cell phones or our bicycles, hockey sticks, but even the bigger structures, they have a limited lifetime. So at the end, how can we be inspired from the human body in order to extend the lifetime of materials and be able to enable this repair that at the end the human body can do? And so that was really the starting point, and people were inspiring themselves from the human body, trying to simulate as well what's happening in the human body with the various different systems as well into self-healing. Many stuff have been researched. And then what has been realized as well is that for many of the applications, when we do that, we tend to either complexify the process and the manufacturing of the composites, or we reduce quite a lot the mechanical properties because we want to give mobility to the materials to be able to heal at room temperature. And so starting with the research that we have done, we changed the strategy and we said, okay, let's not target the stars by having a fully autonomous system, but maybe let's make a compromise and say, okay, those self-healing materials can be also, the healing process can be activated at a certain temperature in order to leave at the room temperature competitive mechanical performances. And actually that's what we have done. That was quite a lot of research with a lot of falls as well, a lot of not mistakes, but a lot of discoveries that were not enough competitive for let's say commercial application, and that was all the purpose as well of the research that we have done at EPFL, so the Polytechnic School in Lausanne, where I did my PhD as well. And then after that, we found a way. And maybe that's where I'm going to stop into there. So, but we found a way, and we said, okay, now we can have the same healing properties that we had before, but having competitive mechanical performances. And for us, that was really something that was important to have in order. And when we made that discovery, we said, okay, there we have something, and we need to go to the next step of, you know, spinning off a research project from a university to a commercial project. That's a long process as well, as you are asking the story behind CompPair. This took time. We decided to spin off the project in 2019. That's where my co-founder Robin has joined me, the professor of EPFL of the university behind as well the technology, was also supporting a lot. She's co-founder of the company, and we started this journey at 3. And then we got the support from various different innovation projects, various startup, as we are considered as a startup as well. So spinning off the project, literally funding the company in 2020, and shifting from 2 full-time people, my associate and myself, the professor being scientific advisor for the company, and then reaching now a bit less than 20 people in about 3 years. Yeah, that's more or less the story behind. Now coming to the composites, I think this is what makes it interesting as well. And also linking, you ask about sustainability. When we started to spin off the project of CompPair, we said, okay, why are we doing that? And I think the first thing to ask ourselves as well when we are spinning off a research project is spinning it off to a commercial project is, why are we doing that? What could be the interest of there? Because research is here to understand the world, to understand many different things, but sometimes the discoveries that we made into research will not necessarily be applied commercially. This will be a building block to go to other big building blocks that suddenly we go to commercial applications. And there, so that's what we ask ourselves. We made market studies, market research into there, and one of the key points with my associate, I think, was also about the impact. What is the impact of self-healing composites onto the industry? What is the impact, and what does it mean to have self-healing composites on sustainability aspect, which is so much important today in our world? And what I like to give as an example is how do we treat waste today? And there is typically, and if you go on our website as well, we like to put that one as the inverse pyramid of how do we consider waste management. And the waste management hierarchy, of course, considers recycling. And recycling is a really important topic that we will also cover today. But recycling is also something where we consider that we continue to produce as we do today. And continuing to produce as we do today has one negative point, is that we don't consider to change the production, and actually changing the production and thinking at the start of the design of the parts and at the materials level, how can we eco-design the parts in order to extend the lifetime, to reuse, to prevent damage to happen, is actually the thing that has the most impact on the waste management and on the resources and on the life cycle of the part. And so for us, it's really important to keep that in mind, that waste prevention and so extension of the lifetime with what we are doing with self-healing composites is one thing that can have the most impact. And this is really part of our vision of the company, to bring full circularity to the composites industry. Extending the lifetime is one big part that can have really a lot of impact, but then recycling at the end of life is also a key pillar that we need to consider, that we have done as well, and I will leave that for later on into the webinar. But so coming to the composites, then the question is how can we bring those composites in an efficient way? How can we bring composites that are compatible with current manufacturing lines? How can we bring composites that are not too expensive neither? And here, I think part of the story behind as well, and I need to give credits to the professor at the PFL as well, who always told me, go ahead with the research, but there is something that you need to keep in mind. Don't try to spend 6 months of producing a sample like this, because otherwise it means that there will be a gap that will be too high in terms of manufacturing. And the laboratory I'm coming from is called the Laboratory for Processing of Advanced Composites. So we always kept in mind of how to bring efficient manufacturing behind, and the prepregs came. And so what we are doing in terms of composites is bringing prepregs. So our products are prepregs, and we will come back to that. And we have specific formulations. So the self-healing is really applied into the resin. Now we are not repairing fibers at all, but we are repairing resin microcracks. And then we use our prepregs onto manufacturing lines to make composites that can repair matrix damage under certain stresses that can have happened over the lifetime. I think I will stop there. What do you think, Thomas? Did you have enough, or?
Yeah, that was a super good introduction. And yeah, I'm actually very fond of what you're saying, trying to come from, or what I take out of your answer is coming from something research and trying to link it now and commercialize the whole thing. I don't know if you have a short follow-up question, Sergio, for Amaël before we go into and look a bit more into detail.
Yeah, I'm curious to know, for example, if your research was based on the matrix, I mean, in the resin, or the matrix material for the composite. Why you decided to go directly from that material to the prepreg for the commercial application, say?
Because we designed the self-healing composites under the form of prepregs, and so this is why basically it came that way. We needed to start somewhere, but it has been designed for prepregs specifically. Okay. And the liquid form, I think we will come back to that after.
Perfect. Okay. So you mentioned a lot the way, so you found a way, and we went to your website and found or YouTube and found a nice video. I think that explains everything, and we actually get a lot of feedback that often it would be good to have some visual aids to support the answers our experts give. So yeah, I think I'll just play the video and you can go along, Amaël, and explain a bit the details. So I think I'll click on play and it should be playing. So yeah, all yours. So
for now, it's only the logo. And so why CompPair? For a composite repair? Huh? You understood that one. Yeah, behind that, I will mention HealTech. HealTech is the product line that we have. So we are bringing standard prepregs, so made of carbon fibers here, or glass fibers, or natural fibers, pre-impregnated with the resin, and that's really the core of what we do into the resin. And then we take the layers, typically for producing composites, superimposed on top of each other, cured, and giving such kind of applications for wind, aerospace, automotive industries, or sports application, for example, that we will just see here with an example, the hockey stick. For example, we have an impact while playing the hockey or fatigue tracks, where you see that there is fatigue and there is the cracks that are growing within the matrix, typical delaminations that you have here. And if not taken seriously, then they will just continue to grow. So we need to repair, but currently we cannot repair such kind of things. With CompPair, we just come with heat, the heat gun, 100 degrees, we activate the mechanism of repair, and then we regenerate the damage fully. This can be multiple times, so this is extremely fast. Globally, in terms of mechanical properties, I will come back to the two other one after. The most important is to show that what you see here, and maybe you have seen us on trade fairs, for example, at GEC recently. We have a nice demo to show you visually how we repair damage, and all that is translated into mechanical recovery as well of the damage. And linked to that, what is really interesting is that this regeneration has a lot of different implications and a lot of different potential really benefits for various types of applications and various types of properties. And because yes, this is regeneration under damage. Here we have seen in terms of sports, in terms of impact, but what we have seen is that regeneration can have a lot of other benefits that I like to see it at two levels, let's say, because as materials provider, we are quite high into the value chain, and our customers are typically part manufacturers, and the customers of our customers are the ones as well that will benefit from the repair. And so we need to look at the benefits of this regeneration at those two levels. The benefit of the regeneration for production can be reduction of production defects, so reducing production cost as well to some extent. We have some customers that have already production defects on their manufacturing line or during manufacturing the composites, or if it's, for example, a boat where you are also having a lot of works into the boat, then there can be an accident, you know, and you need to repair in there. And this is really efficient to use our products for that. And then during the lifetime, in terms of regeneration, reduction of downtime, and two things that we have seen as well is the fact that intrinsically our composites have a higher toughness, in average 30% higher crack resistance. And so this is really interesting for the prevention of damage first. And then those composites have a high damping capacity. So in terms of also absorption of damage, this is interesting.
Perfect. I think you kind of read my mind, because I was going to ask precisely about the applications. So in the video, we've seen some, and you also mentioned where the use cases are. Also, one question we thought could be very interesting is a bit like, what could be the road potentially to use your materials in high performance markets?
Yeah. So currently, CompPair is we are a materials provider. We are providing our prepregs, but we are more than that, let's say, because we have into the portfolio specific reinforcements that we are proposing to customers, where we have data sheets available that we know really well with those reinforcements, all the properties. Then, you know, into the composites industry, there are millions of possibilities to make composites, and so then this is always a case by case with the partner that we need to work, and that sometimes we need to customize as well to specific reinforcement, and this is possible. But then more than that, we are the expert in bringing the healing ability to composites, and so we are here to support. And this is typically something that we are providing as a service as well, as expert into the healing capacity. How do we integrate this healing functionality for specific applications where there is a potential for monetization, this healing, for having economical benefit on top of the ecological benefit, and this is something that we support in. And finally, bringing eco-design and life cycle assessment. We have some experts internally to the team that can do that life cycle assessment for our customers. So all that to say, in terms of applications, that because we can customize to various types of reinforcement, being it carbon or glass that we have seen into the video, we have also worked with natural fibers, with recycled carbon fibers, with recycled glass fibers, and even we have announced also at GEC one collaboration that we have with Airbus to reuse the scraps of their production line. So this is also something that we're doing. And in terms of applications, we can go into all types of applications that use prepregs basically, and that are compatible with the curing process of 140 degrees for those prepregs. Right. Then this is our standard prepreg. CompPair is bringing also other types of products into the portfolio. We have announced the second generation of product recently with a different cure cycle, and we are also bringing the next one, and I look forward that you will discover it as well on our LinkedIn page and announcement into the news. For applications, so what we are targeting is we have a lot of activities into sports. Sports is faster than other domains. This is also an enabler for a lot of different kinds of applications. And we have released some nice use case with Salomon, with the skis. For example, we have done a ski pole that was announced as well at GEC. And we have done a bike frame as well. These are all the public ones that I can share. Otherwise, one thing that is important for us is also all the aeronautical space and mobility track, where we have as well a lot of activities. We received a lot of support from the European Space Agency in the early days of the company, then continued with a mandate and ITT that was announced with Ariane Group, and then we are now continuing the next activities for specifically cryogenic tanks that was announced as well publicly recently. So that's one thing interesting, important for us. On top of different aeronautical applications at GEC, we have also shown a part as a wheel cover for the airplanes that are typically taking a lot of different impacts. And finally, one thing that I know we will discuss later into the webinar, but it is also linked to the wind industry. We had a major development program for the wind, where we have made the section of a wind turbine blade, but it's not with prepregs, it's made by infusion. So we will come back to that later, because now we need to focus on prepregs. Does it answer your question, or?
It does. At least for me. I don't know, Sergio, if you want to add something or dig a bit deeper on some aspects.
Well, I think we can check later with the next slides, because if we are going to speak more about the different formats and that, I think we will widen the applications.
Perfect. Yeah, I think we're getting slowly more technical. So that's good. What is the extent of the reparation capabilities and when there is fiber damage?
So we are repairing matrix damage, so micro cracking. This is where it starts, actually. Or if you have an accident with your car, of course, it's directly fully broken. But then for a lot of different types of applications, you can have static damage bringing by impact, but also fatigue damage that appears progressively, or an impact that then grows because of fatigue stresses. As long as it stays into the matrix material and that it's not too thick, in the order of hundreds of microns, then we are fine to repair. Then if it's open into two, no, we cannot do anything into there without adding any pressure. And most of the time, if it's open into two, it means that there is a fiber that is damaged also. And when there is fiber damage, we cannot repair. But what is interesting is that for many applications, and you see that, for example, with compression after impact testing, that is also standard as a test into the composite field, where we have fiber damage into for some specific conditions, and then we repair and we recover most of the properties. Why so? Because what happens is that the most important into composites, as we have several layers, is to recover the load transfer. And so this is something that is really interesting, that even if there is fiber damage, we can repair also to a really nice extent the damage. Then if it's completely broken into two, no, we cannot do anything, but that's where we can bring the recycling into there. And I think that's the next question.
Perfect.
And Amaël, so in the video we saw like interlaminar cracks, maybe just for the figure, but is your system equally effective for intralaminar cracking?
Again, it depends on the thickness of the crack when you have there. To some extent, yes, it works well. But if it's passing a certain threshold of thickness, then it's going to be more complicated. And if the fibers are not damaged, but with intralaminar crack, you start to have also some fiber damage.
Mm-hmm. Yeah, usually it's a combination. Yeah. And what about the rotation of the parts? I mean, could it be your system, or is it ready for assuming some kind of thermal degradation or radiation degradation, and can be healed after that, or is more a physical thing?
So, meaning the aging, really good question. We have made some healing tests after some aging for specific conditions under humidity and temperature. Yes, it works. Yeah, yes, it still works. Then we would need to check. Coming back to application cases, we can have we can pass one standard for one application with a specific, for example, chemical aging or thermal aging, and then you come for another application and suddenly the thermal aging requirements are 5 degrees lower and you need to redo everything. So it's something, yes, that works. We have done it for specific cases already, and happy on a case by case as well to share what we can do.
Mm-hmm. Very interesting.
Perfect. So next one, I would say, what are the particular approaches for recycling your healable parts? And something maybe very technical, let's see how much we can go into detail. Is the cured material also thermoformable?
So in terms of recycling, and that's coming back to the last question as well, to the extent of damage and linked to the vision of the company, yeah, to also bring full circularity to the composites industry. What we have done was to show that actually those composites have the capacity to be recycled in an ecologically efficient way. And this is important because not all the composites have this capacity, and one crucial point into composites as well, and why this is taking so much time to bring the recycling. Now we are getting there. That's right, that's for sure. But one thing that is highly challenging is how to be at the end ecologically on top of being economically efficient for the recycling. And there we have found a way, again, it's a proprietary one, to be able to recycle those materials efficiently. And this is because of the intrinsic nature of the materials that we are doing that. And this is specifically applying to the healable composites. So our process will not work on the other composites. It's really made for our composites. But we have this capacity. It's less developed commercially as to our prepregs, because our prepregs are here in large quantities. The recycling, we have done it up to a TRL 6, let's say, technology readiness level 6, where we have demonstrated it into a relevant environment. And for this, we have done a really nice collaboration with Decathlon, the sports equipment manufacturer, where we have done the part, we have sent our products to them. They have made the parts that was for a bicycle, and then they sent back the parts to us. We recycled the fibers, only the fibers, and we are focusing only on the fibers. That's where you have the most impact as well. And then we re-impregnated those recycled fibers, sent it back, and we made the closed loop. And for us, that was really important to show that, and to show that this can be done in also an ecologically efficient way. Coming to thermoformability, which is different in my point of view than recycling, we, to some extent, yes, on specific thicknesses and at specific temperature, the materials can move slightly. But again, don't get me wrong, the purpose of those materials and the breakthrough also behind those materials is the fact that at the healing temperature, the materials are still structural. There is for sure at the healing temperature a slight drop in mechanical properties because we are giving this ability to heal, so the material needs to move to some extent. But those materials have typically a TG of 140 degrees minimum. So we are healing below. And that's the most important thing, is to keep the structural properties of the materials during healing. But if we play well with the temperatures, then we can bring this thermoformability on specific thicknesses. And typically for some applications that are produced on the press, we have seen this as a really interesting outcome and really interesting case to bring already cured materials to them for just pressing it, and then you are done. And this is also really interesting for mass volume markets where you do, and then you go to the next step.
Mm-hmm. Good.
Perfect.
So, Amaël, so it's very interesting this characteristic of your material to be recyclable, and I don't know if you can tell us a bit more about let's say the conceptual approach of recycling. If it's more physical, it's more chemical, it's more related to recovering the fibers, recovering your matrix on the side, or you can recover a mix of it and use it for any other purpose with the short fibers. I don't know. Maybe.
I have to say that that's an interesting, let's say, question around what do we do with recycling in composites, because there are always scraps during the production. So if you want to redo exactly the same part, it's going to be difficult.
Yeah.
But what we have seen is this capacity of our composites again to recover the fibers clean and with good mechanical properties in the same shape. And so if you are producing parts that have no scraps at all during the production, and some specific parts have that, then this starts to be interesting for us. Or for maybe really large parts where we can recycle the fibers and then use those large parts of recycled, let's say, reinforcement that are cut for making other parts. But this is the one thing that we have demonstrated, is the capacity to bring back relatively long fibers, or the same size as the part, clean, and therefore this is of interest for many types of applications.
Yeah, I think that the word clean here is also important because many other recycling processes damage the fibers, and especially attack the surface of the fibers and remove the sizing, and everything, and protect the surface of the fibers. And I think that you can provide essentially raw material in its raw let's say performance level. It's quite interesting.
So in here, just one last comment in there. As I said, it's less developed. That's the end of life. So when you want to have a big impact, you need to start somewhere. We started by production of the pre-preg, implementation of the pre-preg, extension of the lifetime. Recycling is at the end of life, so it's going to come after. And for that, we are continuously working also on that, and we are looking for partners to join forces in order to do that. So if there are people in the webinar as well, don't hesitate to contact me on this specific topic.
Great. I think we can come to the last question, if I'm not mistaken. No, there's still another one after this one. Any expectations of distributing a resin in liquid format? So for RTM, for vacuum assisted resin infusion molding, wet layup, others?
Thanks for the question. This is something that we have announced at GEC this year. That we have done the section of a wind turbine blade by Varim, and this was a work that we have done over the last 2 years, conducted by my associate Robin, the CTO of the company. And so we reached a stage where we can provide this technology under infusion, which is really interesting. it's still continuing. We are also looking for applications specifically in there, and that would be the first pioneers into there. And so this is one thing. Then we are continuously improving. You know, the role of CompPair is to bring broadly the capacity of healing to composites. And so this is not only through prepregs. Prepreg is our main activity commercially and with different types of applications. And we continuously as well improve the formulations, and bring new formulations for having different types of specificities for the market. But then it's also getting to other types of manufacturing processes. Yes, RTM is something that we are looking at. And this is also public. We have announced it recently. We are starting the equivalent for Switzerland, but of the EYC accelerator grant for young company to bring healable composites that are made by RTM. So it's coming, and I'm really looking forward as well to have in some time a webinar with you guys specifically on that.
Okay,
Will be great.
challenge accepted. We'll try to get that one sorted. You got some follow-up questions, Sergio?
Yeah, I was thinking about the this liquid format that we are speaking about. Then I guess that you have the ability to change in the material, the viscosity, or to tune it according to the process. I mean, you said that you already performed the infusion of a relatively large demonstrator or prototype. So I guess that the processing window of the resin could be also tailored for the application of the potential customer, I guess.
This is all the purpose is to bring products that are that meet specific conditions or processing windows that are required by the market. And I think this is also something important in a development and in spinning off a technology like this is also to be able to show that this is not only one thing that we are bringing for at one specific UO temperature and that this will never change, but to be able to show that we can really have this broad range of application. And actually that's what we're doing, and that's the beauty of it, and that's the true beauty of CompPair as well, is this capacity of bringing the healing capability broadly into composites.
Yeah, I see the flexibility now of the whole range of products that you can bring to the market. Yeah, also, for example, in automotive field, it is very extended, the SMC process, which has to do somehow with the prepregs. So I'm wondering whether you also have this in your roadmap of development.
Joker. No, yeah, everything can be imagined. Everything can be imagined.
Perfect. And I think we can come to the final question before we leave space to Q&As. It's more or less 45 minutes, so we're right on time. Great. So the webinar is about self-healing composites for sustainability. So we tried to touch on different aspects throughout the interview. And yeah, just to wrap it all up, how you think, I mean, you touched upon it, but I think it's good to kind of have this closing question. How do you think self-healing composites help achieve the sustainability goals?
Yeah, that's true. I did touch the element, and I think it's a good closing as well question in order to show that again lifetime extension is key in order to help achieve those goals. But this needs as well to be a balance between how can we extend the lifetime, get the highest impact, but also bring something that is meaningful for the application, and that this is a win-win situation for everyone along the value chain, let's say. The extension of the lifetime, and let me give you a simple example. We cannot believe how the regeneration can bring and the repair can bring this kind of aspects, because we can change the layups into the applications. We can also use those materials as a protective layer, for example. That's the example that we have done into the skis, where we can remove potentially the top sheet. That's the work that we're doing. And therefore, if you remove some materials, you save some resources, and therefore saving some CO2 emissions. Then on some applications, we have seen that we can extend the lifetime on some applications where people are just throwing away parts, and where they are replacing it. And what we have seen is that replacing and even the traditional patch repair mechanism has quite a lot of impact along the life cycle of the part, and that just repairing with a 1 minute with a 1 minute heat with a heat gun, is the impact is only the electricity of the heat gun. And we have done a life cycle case for an internal part that we had, and what we have seen is that in comparison to throwing away the part and reproducing one and just repairing it, you have more than 99% reduction CO2 emissions, which can seem logical, but at the end this shows you that repairing is so much important in order to bring that sustainability aspect and reach the sustainability goals, that we need that change, and we need to do that in order to extend the lifetime and reach those targets.
Yeah, I think that you get to an important point in the effective reparation processes, because in the composites field, we all know that it's always hard, no, to get the a simple reparation process for laminates. Usually we need to raise part of the laminate. We need to add patches, you know. So and also maybe other means of reparation might consume much energy than even if you produce the part. So it's like yeah, it makes not so much sense from the energetic point of view. And in this case of your material, I was asking myself if the cycles of reparation are virtually, let's say, infinite, so they can be reproduced many times, or did you find out that there is a, let's say, a limitation? I'm speaking without any fiber breakage. I mean, eventually there's no fiber breakage.
Everything has a limit. Everything has a limit. But yeah, theoretically, we did one test and we stopped at 60 times, because then it was days and night, and we said, okay, we stop. But we stopped at that time. Then there might be some applications where we go above, and when we are into such kind of implementations, then we will do the test specifically, but we stopped at that number.
Yeah. So yeah, I was asking because well, in the case of, for example, in thermoplastic chemistries, yeah, you can essentially melt them and solidify them infinite number of times. But if we are more, let's say, more precise with the chemistry, we'll see that we have, in every cycle, we have some kind of polymer degradation phenomenon and so on that prevents us to do it, you know, many times without losing part of the performance of the material. And that's why I was asking you. But I think that 60 times of preparation is in this composite field is, I think, is a large enough large number to get interest.
Perfect. Great. I think it's time to give everyone else space to ask. questions, not only to myself. So let's jump to Menti again. And again, I see there are already some questions. So that's good, just for everyone to know, because I've seen people raising hands in Zoom, etc. To send through your questions, please go to menti.com, and then you can use the code that you can see on the top of the screen now. Okay, and then through there will be a button, and you will be able to send your questions. Okay, I think we can start. And yeah, Sergio and Amaël, feel free to answer if you feel comfortable to answer, of course. So I'll read out the first one. Hi, happy to join us. Will on the future self-healing composite food grade compatible for water contact?
What a question.
Yeah, looking at that question, again, all the work is possible, and our purpose is to build new chemistries that are healable. So why not? It all depends on what specifically we are meaning behind that. But happy to discuss more of that.
Yeah, I cannot see by now. I mean, in the moment, any application in which we would need. Maybe there is this attendee has the particular application, but I cannot see it like food grade compatible for and self-healing in the same context. It's hard to imagine.
Okay, I think I can answer that one as answered. I marked that one as answered. Okay, next one. This is a bit shorter. 3D printing future solution with your product?
Not a focus for now, unfortunately. Yeah.
In the future, we'll do a webinar on the topic. Is the composite technology of CompPair adaptable for protrusion manufacturing? Are you going that direction? Interesting question, I guess.
Yeah.
It's looking at different processes that we have, and then step by step. Again, the focus was on pre-preg, then the compatibility to liquid format, then of course there are some next logical steps that may come, and this will be based on the resources that we have access to in order to do that as well, and the focus of the strategy at that time, and the opportunity that we see behind that. Again, there are, to be clear, and it's also coming on the why that I was speaking of at the beginning. There are some applications that do not make sense, and we need to be aware of those ones. And some applications where you have composites that are used really remote into a big part that will never be dismantled in order to reach also the repair with the heat, and maybe there it's not going to make sense, or a part where we use it for its lightweight properties, but that will never be under high load stresses or will never be prone to any impact damage. And there, this might make less sense. And this can be, and I'm telling maybe some stuff that are not right in there. We don't want to take any specific example, but this can be for here for protrusion, maybe an application where this would make less sense into there. But yeah, depending on the opportunity that we have at that moment, this might come. Not
right. Not for now, no? Perfect. Which materials generally use a healing material? Also, which type of change in mechanical properties we find after the healing?
So I'm not sure I get the first part, but in regards to the second part, we come back to the initial original mechanical properties, and that's the interest. And again, also happy to exchange more on that with some proof of what I'm saying, with mechanical testing where you see clearly the recovery of the damage, the full recovery of the damage.
You want to add something, Sergio? I saw you muted. Maybe yes.
No, yeah, I was trying to wonder what the first question refers to. But yeah, going to the second, yeah, I think Amaël explained very well that we can go back to the initial ones. Well, maybe mechanical property. Yeah, maybe I guess you assessed the most typical mechanical properties, or you went for a full testing campaign of all of it?
Yeah. So at coupons level, at materials level as well, and then for on the parts. And this is again our job. Really interesting to launch some campaigns of healing and of durability on some parts, and you know, you have parts that are coming into our offices, and that on purpose we start to destroy the parts before the first use, and that's our job. And it's really fun sometimes to see the parts coming back, and then the team that starts to bang on the part because they want to get the damage and to see how it repairs and how the durability can be kept.
Perfect. I hit this one as answered as well. For CompPair, how does it work? Your internships or jobs? If we are in LATAM, is it a good idea to apply? Thanks. This point for you, Amaël.
Always interested to have internships and jobs. We have. I invite you to go on our website. There are different job openings as well. And when we receive a CV, we consider all the CVs, so we go through all of them. Please sometimes allow some time as well, because I don't know why, but sometimes the applications come all at the same time, and suddenly you have a lot of applications at the same time. It takes a bit of time to treat them, but we are doing our best.
Perfect, thanks. It's one of our students for sure. Any suggestions for reading material to better understand self-healing composites, the diavascular structure and distribution of the healing resin, and layer structure of the composite? I guess it goes for both. If you
So it's in general self-healing composites, no? I think the question is related to that in general. What is a good reading? There are thousands of reviews, there are thousands of reviews, thousands of open access reviews as well. But I have to say, start with the maybe at the research level, for labs that are well known, with professors that are specialized into self-healing composites and which have published some reviews, and then you will get to know everything into there.
Perfect. 6 questions left. Firstly, thanks a lot for this very beneficial webinar. Thanks for joining. Does CompPair healable prepregs work with regardless of manufacturing method like autoclave, RTM, etc.? And do these require some curing cycle? I think we partly answered this, but maybe you want to stress
answered
again?
that one, yeah. Perfect.
Is the prepreg based on Vitramer's chemistry? How is the compatibility with epoxy or VE resins?
Vinyl ester
resins, yeah.
So no, it's not a Vitramer, and the main also characteristic, as I said before, is that when we repair, we keep the structural properties of the part. Then in terms of compatibility with other resins, you mean maybe having co-cured part or bonding to some extent on some other part? Yes, this is compatible, and we have done some specific applications into that.
Okay, great. 4 questions left, if there are no new ones coming up. Do you use epoxy or UP resins, and what are the criteria for thermoplastic phase? Thank you. Similar to the previous one, I guess.
Similar to the previous one, I think I answered that one.
Yeah, I was gonna say. Perfect. Marcus was answered. Is healing/recycling process of the prepreg possible when there is coating on it?
Oh, very good question.
Really good question. So yes, we have some compatible systems. We can apply specific paints on it, specific gel coats, and happy to provide also the answers to that. And we have some specific systems that are compatible in terms of coatings on the final composite.
Great. Two more. Could you please explain the healing mechanism and the equipment required to do self-healing?
So it's a heat trigger. So as long as you go to 100 degrees, it heals. So it's the standard heat gun that we use. We have many videos on the website. I invite you to check those. You will see that, or to come and visit in Lausanne, or on the trade fair, and happy to make a live demo. So behind that, it's really coming to the healing requirements and mechanism behind that during a practical case. It's bringing heat, no pressure to add, so you leave it on site. This is really the most important part as well, is not having the need to remove the part from maybe the part that is damaged from a bigger application, or for example an airplane. If there is a part that is damaged, you don't need to like dismantle the part and put it back into the pressure or the mold. Then you can just do it on site, and that's really the main purpose of using also CompPair products.
Perfect. I think there's one more. Yes, there is. Perfect. I think we had this also unanswered. So open to international job applications, like from Turkey. So I think you answered. Yeah. You just need to go to website. Go ahead.
Yeah, I answered. Yes, we are open to international jobs applications, and so feel free to apply.
Perfect. So we answered all of them, and I think, yeah, that's a wrap. Thanks everyone for joining, for sending your questions, and a huge thank you to Amaël for accepting our invitation, for shedding a bit more light on what's happening in the area of self-healing composites and how that can benefit the whole composite sector. So thank you very much, and also for the passion you transmit and all the questions. I loved it. And thanks Sergio for joining me and giving a nice technical touch to all the questions. And yeah, I think that's it. Thanks everyone again for joining, and that's it. Have a good one. Thanks again, Amaël and Sergio, and see you hopefully soon for another webinar.
Thanks a lot for the invitation, and yeah, see you soon. And for all into the webinar, don't hesitate also to contact us for any further questions or any interest as well.
Perfect.
Nice. Thank you, Amaël.
Thank you.
Great.
Bye.
Bye.